Hello again, Algebra 1B. So we're going to keep on moving forward with systems, right? And today we're talking about more substitution, right? So earlier this week we were talking through substitution when both equations were like y equals mx plus b. So there's another type of substitution that we're going to do today, right? It's still called substitution, right? Not confusing at all, right? But this is when we have one equation in standard form and one equation in slope-intercept form. Right, so remember that when we're talking about standard form, those are those ax plus by equals c sort of looking things, and slope-intercept is that y equals mx plus b. So the difference with these, obviously, is that one of them doesn't have the y all by itself. Right, but we can still use substitution to solve them, right? It's not going to be too bad. So our steps are that we're going to substitute the slope-intercept equation into the standard form equation. Right, so let me kind of try and walk through what that means. So the slope-intercept equation is y equals mx plus b. Right, so we've got that mx plus b part that y is equal to. So what we're going to do is we're going to take that and we're substituting it in for where the y is in the standard form equation. Right, because if y is equal to mx plus b, we can shove that in for where the other y is. After that, we're going to have an equation that just has x's floating around. Right? We can solve for a variable. We then substitute that back into one of those original equations and solve for the second variable, really similarly to how we did things a little bit earlier in the week. Okay, so again, one of those things that's probably a little bit easier to work through and kind of see as we're doing it. So right off the bat, we're getting a little bit of a curveball here. This one we've got that x is equal to 2y minus 4. So x is equal to this chunk of stuff. If I'm looking at the second equation, it's 3x minus 5y equals negative 11. So this has got 3 times x minus 5y equals negative 11. So what we're going to do is we're going to take 2y minus 4, and we're going to put that in for that x. Because if they're the same thing, we can smush one in for the other. The way that that's going to look is like this, right? So we're going to take 3 times that x that we're plugging in, right? So in this case, that's this 2y minus 4, right? Then we got the rest of it, minus 5y equals negative 11, right? So what we've done here, right, is we've literally just taken x is equal to 2y minus 4. We've substituted that into the other equation for the x. From here, it looks a little bit gross, I'll give you that, right? But what we're doing is we're just doing the same sort of algebra that we normally do. Right? What I'm going to do is I'm going to take this 3 on the outside of the parentheses. I'm going to multiply that into the parentheses. Right? So now that we've done laws of exponents and all that kind of good stuff before, right? But it's nothing super fancy, right? This is just regular distribution with these parentheses. So that 3 times that 2 is going to give us 6 with the y. 3 times negative 4 is going to be negative 12. We bring everything else along. After that, I've got some like terms that I can combine. Right? I've got this 6y and this minus 5y that are on the same side. Don't fall into the trap of doing the whole like, oh, we got to do the opposite sort of deal. Right? Because they're on the same side, this is just 6y minus 5y leaves us with 1y. Still got that minus 12, and it still equals negative 11 on the other side. Right? As we've talked about in the past, right, that 1 in front of the y is optional. Oops. The y is not optional, but the 1 is optional. There we go. All right, so what we can do is we can set it up just like that. Now that all my y's, like they're all contained on one side, which is kind of nice, they're all on the left, that means that I need to move all my other numbers, so like that 12, over to the right. So I'm going to add 12 to both sides. All right, when I do that, I'm going to get negative 11 plus 12 is 1. Y is 1. But wait, there's more. Right? We still need to plug this 1 back in to solve for x. So when we're plugging these back in to solve for the second variable, there is usually an easier option, right, of the two original equations. I'm going to choose the one up top because x is already by itself. X is equal to 2y minus 4. It sounds a lot better than plugging it into 3x minus 5y equals negative 11 and having to like sort through a whole bunch of junk to get the x by itself. So what I'm going to do, I'm just going to replace that y with what we found it to be, which was 1. Right, so this is going to be 2 minus 4, and And 2 minus 4 is negative 2. Cool, done. That's it. Right? So again, pretty similar to how we were doing substitution earlier this week with the two, like y equals whatever. Right? Pretty similar, except for that first step. Right? So the first step is the tricky one. Okay? Let's try another one out. So again, we're solving this one by substitution. I've got that y is equal to 2x plus 12 for that second equation there, right? So you notice that my eyes are jumping directly to the one where it's just the variable by itself, because that's the one that I'm going to need to like substitute into the other equation. The first equation was 3x minus y equals negative 2. Right? So because y is equal to 2x plus 12, I'm going to plug that in for that y in the first equation. Right? A little bit of trickiness going on here. Right? We got 3x minus, and then it's still important to put parentheses around this when we're plugging in the y. Right? 2x plus 12. Actually, let me kind of do it another color just to kind of match what we were doing before. Alright, so all I'm doing this step is I'm just plugging in what y is equal to into the other equation, right? Putting parentheses around it, because as we see, there's a minus in front. Right? So that minus is actually going to affect everything that's on the inside. If it helps to think about it this way, there's always like an invisible little 1 in front of parentheses, so it's like there's a negative 1 that needs to distribute into there. When we take care of that distribution, right, it's just going to basically flip all the signs of everything on the inside, right? So this is now minus 2x and minus 12, and everything else stayed the same. Right, cool. So similar to the last one, we've got some like terms that we can smush together here, right? We've got 3x minus 2x. Again, they're on the same side, so it's just 3x minus 2x, which is just 1x. Right, and again, we don't need the 1 there. I'm going to get rid of it. After that, we just need to move all the numbers to the other side, right? So plus 12, get that over to the other side there so that the x is all by itself. Negative 2 plus 12 is 10. Cool, so x is 10. But wait, there's more. And so what we're going to need to do here, right, is we're going to take that x equals 10, smush it over to the side, we're going to plug it into one of those original equations. I'm thinking that the second one, y equals 2x plus 12, is going to be the easier one. Alright, so all I'm going to do, I'm going to plug that 10 in for x. Alright, so this is going to be 20 plus 12. That's going to mean that y is equal to 32. Right. So if the second part of this seems really easy, right, like, oh, I found that x was 10, and oh, I'm plugging it back in, that's good that it seems easy, right, because it's the same thing every time, right? We're just finding out one variable, and then plug it back in and find the second one, right? It's just hopefully figuring out what to do for this first step right at the beginning that's the tricky part. Okay, let's try another one out. And oh my gosh, this one has a fraction. Oh gee, the worst. Sorry. So what we've got here is that 4y minus 2x equals 2, and x is equal to 2/3 y. So x is equal to 2/3 y. Well, what we can do is we can plug that in for what x is, right? Because x is equal to that. Let's plug that in. So we've got here is 4y minus 2 times 2/3 y equals 2. Right? Might make you want to throw up just a little bit, right? But we'll make it through. It'll be okay. So again, when we're multiplying with fractions, right? This is negative 2 times 2/3, right? It's never a bad idea. You can do this off to the side. Negative 2 times 2/3. We can put that negative 2 over 1, right? Because anything divided by 1 is itself. If we multiply the tops, that's negative 4. Multiply the bottoms, that's 3. So what we're going to get here is that that turns into negative 4/3 y out of those parentheses. Right? So now our problem looks like this. 4y minus 4/3 y equals 2. Right? So again, something that I like to do whenever I'm kind of at this point, there's no parentheses to mess anything up, I can get rid of the fraction. Right? The reason that we wanted to make sure that we took care of the parentheses first is that sometimes it can be a little bit funky if you try and get rid of them when there's parentheses still hanging around. So now that we don't have parentheses anymore, let's get rid of the fraction. The only denominator that we're trying to get rid of is the 3, so I'm going to multiply everything by 3. So 3 times 4 is going to be easy, that's 12 with the y. Using our little shortcut that we've run into in the past, or you could do it out as 3 times 4/3. Right, put the 1 under there, you get 12 divided by 3. Spits you out with just 4. This is minus 4y. And then don't forget to bring that over to the other side as well. 3 times that 2 is going to give us 6. Right, now I've got some like terms here. Right, I got 12y, and then I'm subtracting 4 more y's. It's going to bring me down to 8 y's equals 6. And then, oh my gosh, it's going to be gross. Sorry. We're going to divide both sides by 8. What we're going to find is that y is equal to, oh yeah, it's just 6/8. Wow, so much fun. Isn't that great? We can actually reduce that a little bit to make it look a little less awful. Right, so y is equal to 3/4. So we do have to plug this back in. So sorry. Right, to figure out what y is. And you're not going to like me for this, but what I'm going to do is I'm going to plug it into that second equation. X is equal to 2/3 y. Right? The reason I'm going to choose this one is because there's really only one step we have to take. Right? We just have to multiply the two fractions together, right? Because y is equal to 3/4. So I can plug that in just like I wrote there. So all we got to do is we're just going to multiply the fractions. The top multiplies the top. 2 times 3 is 6. The bottom multiplies the bottom. 3 times 4 is 12. Wow, cool. We can simplify this a little bit, right? 6/12 is the same thing as 1/2. So y is equal to 3/4 and x is equal to 1/2. And we made it through that. Oh my gosh, it's over. Oh my god, it's done. And it wasn't that bad, right? We all made it. So fractions are going to still seem a little bit scary with these, but we can do it, right? Just take it one step at a time. Oh my gosh, decimals. Ew. So let's kind of run through how to take care of one with decimals as well. So starting off, kind of the same way. I'm just going to take a look at the equations I have. I know that y is equal to 0.4x minus 2.4, and then 4y minus 10x equals negative 18. Right, so again, I know what y is equal to, so I'm going to take this chunk from the top, I'm going to plug it in for that y in the other equation. Right, it's going to look a little gross, so bear with me. Right, we're going to have 4 times all that junk from the first equation. 0.4x minus 2.4. Right, and then we bring the rest along. Minus 10x equals negative 18. Alright, cool. So again, I really do like to get rid of things like decimals and stuff like that. You can leave them as decimals too, right? That would also be fine. But we do need to take care of that distribution. So I'm going to distribute that 4 into the parentheses. So 4 times 0.4, you're welcome to use a calculator, right? I know it's going to come out as 1.6x. And then 4 times negative 2.4 is going to give us negative 9.6. Alright, cool. So now we're here, right? We have a couple like terms that we can combine, right? So if you like doing it with decimals, right, and just using a calculator and doing the decimals and all that throughout, that's fine. You're welcome to do that. If you're somebody like me that doesn't really like decimals and wants to kind of get rid of them, here's a little trick that you can do. Right? You do not need to do it this way. You can if you want to. To move a decimal place, all you really do is you just multiply by 10, and it'll move the decimal place 1 to the right. So if I multiply everything in here by 10, what's going to happen is that 1.6 is going to turn into 16 because I'm moving that decimal point. So now this is 16x. Same thing is going to happen to 9.6. That decimal point is going to move 1 to the right, so it's going to become 96. 10 times 10 is 100, and then 10 times negative 18 is negative 180. Right, so the numbers got very big very fast. Right? We're still faced with pretty much the same problem. It's just that now it doesn't have decimals, if that makes you feel a little bit better about them. Right? For me, it does. Right? If you wanted to do it out with a regular decimal way, you should hopefully end up with the same answer here. Right? So I've got some like terms. I've got 16x's minus 100x's on the same side. So 16 minus 100 is negative 84x's. we've got that minus 96 equals negative 180. All right. Because all my x's are over on the left, I need to move all my other numbers, that 96, over to the right. So if I add that, I'll knock it out from over there. What we got to do is we've got negative 84x equals, and on the other side we're going to get negative 84. Wow, that came out pretty nice. If we divide both sides by negative 84, I find that x is real nice. X is just 1. Not too bad. But wait, there's more. Alright, so what we got to do here, right, we're still plugging it back in. I'm thinking that plugging it into the one with decimals is actually going to be a little bit easier for us. 0.4x minus 2.4. And so y is equal to, we're going to replace that x with the 1 we just found it to be. Right, 0.4 times 1 is just 0.4. Oops, minus 2.4. And then 0.4 minus 2.4 is going to give us negative 2. Right? And again, when you're working through any of these types of problems, you can always use a calculator if it makes it a little bit easier. Right? It's never a bad idea to get the extra practice in, you know, doing it in your head or doing that on paper. Right? But if it speeds you up a little bit, calculator's fine. Right? But that's our answer. So what we're going to do is we're also going to talk a little bit about some word problems. Right? Because you might be thinking so far like, oh, well, this is all fine and dandy, but like, how does this actually look when you run into it in other situations, right? So with this one, I'm sorry in advance for the funny voice, but I love doing it. So for this example, a grandfather likes to play guessing games with his grandchildren. He tells them, I only have dimes and quarters in my pocket. They're worth $3.85. Oh boy, I have 14 less quarters than dimes. How many of each coin do I have in my pocket? Alright, so what we're going to do is we can set up a system of equations that'll help us figure this out. Alright, so there's a lot of different moving pieces going on here. So we know that we only have dimes and quarters to worry about. We know that altogether they're worth $3.85. We also know a little bit about the numbers of how many of each. Right? He has 14 fewer quarters than dimes. Right? We're trying to figure out how many of each coin he has in his pocket. So the how many of each coin do we have, right? That's how we're going to know what to set this up with. So we're talking about quarters and dimes. We're trying to figure out how many of each. So what I'm going to do is I'm going to set up two variables. I'm going to say that Q is the number of quarters and D is the number of dimes. All right. So now that I've got something I can work with, I can set up some equations. All right. So I'm going to give myself a little squiggly there. All right. Set up our system. We're going to need two equations. So I'm going to start with they're worth $3.85 first. So if we've got some sort of money, right, we've got quarters and we've got dimes, and we're trying to relate them to $3.85, right, Q is the number of quarters. So if I had 4 quarters, I'd know I had $1, right? That's basically like in your head saying like, all right, I had 25 cents times 4, that gives me a full $1. So one way that we could write out the value of the quarters for this part of this equation is that it's 25 cents, 0.25, times the number of quarters, so 0.25Q. Right? Say we can do the same thing for the dimes, right? We're adding on the value of the dimes. The dimes are only worth 10 cents. And we're multiplying that by how many we had, right? If I had 3 dimes, 0.10 times 3 gives us 30 cents, right? 3 dimes. Altogether, that comes out to be $3.85. Right? So that's the equation for that little bit piece of information in yellow. Right? Seems like we can get a whole lot out of there. And I know it looks really awful, but we're going to work through it together. Right, we just got to get that other equation set up. He also says I have 14 less quarters than I do dimes. Right? So the number of quarters is less than the number of dimes. So if I take the number of dimes we had, and I take 14 of them away, that's how many quarters we have. So D minus 14 equals Q. And that's what we get from that little pink piece of information. All right, so now we've got our system all set up to go. we can actually solve this out the same way we were doing problems a little bit earlier, right? So I'm going to use a third color of highlighter here, sorry. We know that Q is equal to D minus 14. Well, we know that there's a Q in that first equation. So all we're doing is we're plugging that in right there, right? Same kind of idea as what we started everything off with. So what we're going to have is 0.25 times that piece that we're plugging in, D minus 14. Somehow we're switching colors all over the place. All right. Is just going to go in for Q, and then the rest of everything stays the same. 0.10D equals 385. Okay. So just to kind of, make it so it's not teeny tiny on your screen, I'm going to zoom in a little bit over here. So this is where we are now that we've plugged in and substituted. So then from here, we do have to distribute that 0.25. Right? What that's going to give us is 0.25D minus, if I use a calculator for this, it's going to come out as minus 3.5 when we do 0.25 times negative 14. And then everything else stays the same for now. Alright, sweet. So what we've got is we've got some like terms. Again, they're on the same sides. You don't need to do the opposite thing. It's just 0.25 plus 0.10. If you imagine you're adding a quarter plus a dime, that's 35 cents. So 0.35D minus 3.5 equals 385. Okay. What we're going to do is we're going to have to move that 3.5 over to the other side. So we'll add it there. We're going to get 0.35D equals, it's going to come out as 735 there. Right, again, using a calculator through this, I'm not just like whipping these numbers together in my head. All right. And then, especially not for this one, we're going to need to divide by 0.35 on both sides. All right, so when we do that, D is equal to, and that's going to come out as 21. All right, so altogether, we had 21 dimes. But wait, there's more. So now that we know that there were 21 dimes, we got to come back to these original equations, right? I'm actually going to do a little bit of movie magic here. I'm going to squeeze those down a little bit so we have a little bit more room. So now we know that there are 21 dimes. I'm going to need to plug that back into one of those original equations, right? I need to figure out how many quarters we had. So what I'm going to do is I'm going to plug it into this one. D minus 14 equals Q. It looks a whole heck of a lot easier than plugging it into that first equation there. All right, so instead of D, we had 21. So plug that on in. 21 minus 14 is 7. So we had 7 quarters and 21 dimes, and that's it. That's all we got. All right. So these word problems can get a little bit tricky, right? But overall, right, other than maybe needing to use a calculator a little bit, the hardest part about the word problems is just setting up the system, right? If you can get that under control, then you're all set to go for the rest, right? So one last problem, and then I swear I will stop talking. Here is an exercise from an 1881 algebra textbook back in the days before Instagram and Snapchat and telephone section. I think that telephone was around. But anyway, a farmer purchased 100 acres of land for $2,450. He paid $20 per acre for part of his purchase and $30 per acre for the rest. How many acres did he buy at each price? All right, so same kind of deal. We have some information here. We can set it up as a system of equations. So one of them is that we know he purchased 100 acres total, and they came out to $2,450. Right? So I know that that piece of information, because it's all in the same sentence, seems like it all goes together, but I'm going to kind of let you know a secret. This 2,450 is going to go with the other bit. Right? He paid $20 per acre for part of it, and $30 per acre for the rest. And we want to figure out how many acres we bought at each price. So how many acres at each price means that what we're going to need to do is we're going to need to set up some different variables. All right, so let's say that X is the number of acres at $20, let's say that y is the number of acres at $30. Right? So X is the number of acres at 20 bucks. The Y's were a little bit more, they were 30 bucks a piece. All right, we still need to set up our system here. So let's start off with the 100 acres, right? That one's going to be pretty easy. All right, so 100 acres of land, that means that altogether X plus Y, right? If we had some number of acres at X, some number of acres for Y, altogether there were 100 acres total. If you just add them together, you get 100. Cool. That part of the equation is all set up. That's what we get from that yellow bit of information. What we get from the pink is going to be, sort of along the same lines as what we did for the coins, right? It might be a little bit more straightforward. Right? So $20 per acre for all of the acres that we bought with X. So that's going to be $20 for each one of those acres that we grouped into X. We're then adding on the cost, $30 for each one of the acres in the Y group. And then all together that comes out to $2,450 dues. Man, can you imagine buying 100 acres of land for under 2,500 bucks? That sounds pretty sweet. Anyway, so what we're going to need to do here is we're going to solve this out using substitution. But you might notice something's wrong. We don't have one of these equations that's already solved for one of the variables. Right? So what we're going to do is we're going to kind of cheat the rules a little bit. Right? I'm going to take this top equation. I'm just going to rewrite it down here real quick. Right? X plus y equals 100. Not changing anything about it. Right? And what I'm going to do is I'm going to make it so that there is one variable by itself. So the way that I'm going to do that is I'm just going to solve and get one variable by itself. I'm going to move this x over there. Right? When I do that, I'm going to get that y is equal to 100 minus x. Right? So even though we didn't start off with something that seemed like, oh cool, we're good to use substitution, we can just run with it. Right? We can change things up a little bit and make it work that way. So now that I know that y is equal to 100 minus x, right? 100 minus x can go in for this y in the other equation. Right? So I know we're running a little bit long. I'm going to kind of pop that in there. 20x plus 30 times that chunk that we're plugging in, right? 100 minus x, right, equals 2,450. Right? And then again, once you get that first step all set and done, it's just algebra, right? We're going to take that 30 and we're going to multiply it into those parentheses. So it's going to be 3,000 minus 30x equals 2,450. You can zoom in a little bit more on that part. We've got some like terms. So again, they're on the same side. You don't need to do the opposite thing. This is just 20 minus 30, which is negative 10 x's. Bringing everything else along with that plus 3,000 equals 2,450. We'll move that 3,000 over to the other side, right? Get that away from where my x's are. So get that negative 10x is equal to, what's that going to be? Negative 550. Divide everything on each side by negative 10 to get rid of that coefficient. And we're going to find that x is 55. And so that's telling me that we had 55 acres in that X group, right? So we paid $20 an acre for 55 of them. But wait, there's more, right? We still got to figure out what y is. All right, so one of our original equations was x plus y equals 100. Right? Well, if x is 55, 55 plus y equals 100. If I subtract that 55 to get that y all by itself, what we're going to find is that y is just 45. So we had 55 acres at 20 bucks a piece, 45 acres at 30 bucks a piece, and that's the end of the problem. Right? So again, setting up the system is maybe a little bit tricky. It takes practice, right? That's really the best way to get good at them, is to just practice with them. Take a look at more examples, right? After that, it's just substitution, like we've been talking about all throughout this whole half hour together. Oh, so nice. Anyway, I'm out of here. Make sure to check back on Google Classroom and reach out to your teacher if you need help. See ya!